For a century, the tank's survival relied on the thickness of its steel skin. But in the modern age, armor alone is no longer enough.
Anti-tank guided missiles have become faster, smarter, and more lethal, capable of piercing even the thickest composite armor. You can only add so much weight to a vehicle before it becomes immobile. The race between armor and shell hit a dead end. To survive, engineers had to think differently. Instead of taking the hit, what if the tank could stop the bullet in mid-air? This is the era of the Active Protection System, or APS, an intelligent defense network that acts as a tank's personal bodyguard.
APS technology is divided into two categories: soft kill, which confuses the enemy, and hard kill, which destroys the threat.
Soft kill systems, like the Russian Shtora, use infrared jammers to confuse the guidance systems of incoming missiles. They can also deploy multispectral smoke that hides the tank from laser designators and thermal sights.
But soft kill relies on trickery. If the missile is unguided or too advanced to be fooled, the tank is still in danger. That is where hard kill systems come in. They don't hide, they shoot back.
The Soviets were the pioneers, deploying the Drozd system in the 1980s, the first operational hard-kill APS.
It used primitive radar to detect threats, and launched a simple unguided rocket to intercept them.
However, early systems were dangerous to friendly infantry, showering the area with lethal shrapnel.
Western armies initially hesitated, preferring to rely on superior composite armor, like Chobham.
But the urban battlefields of the 21st century changed everything. Threats could come from any direction, at close range.
Israel, facing constant threats from advanced ATGMs like the Kornet, realized they needed a better solution.
Rafael Advanced Defense Systems developed Trophy, known in Hebrew as Windbreaker.
The heart of Trophy is its radar, which provides 360-degree coverage, scanning for incoming projectiles.
When a threat is detected, the onboard computer classifies it, determining if it will hit the tank.
If a collision is imminent, the system rotates a launcher and fires a specific countermeasure.
It uses multiple explosively formed penetrators, essentially a tight shotgun blast, to shred the missile's warhead.
Unlike the early Soviet systems, Trophy focuses the blast to minimize the risk to friendly infantry nearby.
Trophy made its combat debut in 2011, successfully intercepting an RPG fired at an Israeli tank.
In subsequent conflicts, it reportedly achieved a near 100% success rate, saving countless tanks and crews.
The system forced enemies to change tactics. The fire and forget era was meeting its match.
Impressed by its performance, the U.S. Army rushed to install Trophy on its Abrams fleets for European deployment.
But protection comes at a cost. The system adds significant weight and power consumption to the vehicle.
Retrofitting existing tanks requires complex rewiring and balancing, often looking like a bolt-on addition.
For lighter vehicles, systems like Elbit's Iron Fist were developed, using a smaller combustible mortar projectile.
While Trophy uses kinetic pellets, Iron Fist uses a shockwave to shatter the incoming missile's integrity.
Germany's Rheinmetall developed Strike Shield, integrating the sensors and countermeasures directly into the armor plates. Russia returned to the game with the Afganit system, designed for their next-generation T-14 Armata.
Russia claims Afganit can intercept not just missiles, but potentially high-speed uranium tank shells. A bold claim.
Intercepting a solid metal rod moving at Mach 5 is exponentially harder than stopping a subsonic missile.
While the Armata is rare, Russia is also updating older tanks with the Arena M system to counter modern ATGMs. China has developed its own systems, like the GL-5, offering active protection on its export tanks.
An arms race is underway. As APS becomes common, missile designers are already working on ways to defeat it.
One weakness is saturation. An APS has a limited number of shots and can be overwhelmed by simultaneous attacks. If the reload time is too slow, a second missile following the first can penetrate the defense.
We are witnessing the death of the passive tank. In this new age, a tank that cannot think and react is simply a steel coffin.
Weapons like the RPG-30 fire a small precursor rocket to trigger the APS, clearing the way for the main warhead.
Top attack missiles like the Javelin strike where the armor is thinnest, presenting a difficult angle for early APS radars. Newer generations of APS are expanding their radar cones to create a true hemispherical shield.
The rise of cheap suicide drones poses a new challenge. Can an APS track and engage a slow, small bird?
Future APS will likely integrate electronic warfare, jamming the control signals of drones before using hard kill methods.
Laser systems are being tested to provide an infinite magazine of defense, limited only by electrical power.
However, lasers require massive amounts of energy, demanding new engine and battery technologies.
APS radars also double as sensors, giving the crew unparalleled situational awareness of the battlefield.
Systems now feature slew to queue, automatically turning the main gun towards the source of the incoming fire.
While interception is automatic, the counterfire often remains a human decision to prevent accidents.
Modern systems are designed to be modular, allowing for quick repairs and upgrades as threats evolve.
The biggest barrier remains cost. Outfitting a fleet with APS can cost nearly as much as the tanks themselves.
Despite the cost, major powers are moving to make APS standard equipment on all frontline vehicles.
APS allows lighter tanks to survive on the modern battlefield without carrying 70 tons of steel armor.
Infantry tactics have had to adapt. Soldiers must now keep a safe distance to avoid the APS backblast.
Friend or foe identification is critical to ensure the system doesn't engage allied vehicles or projectiles.
The conflict in Ukraine has provided a brutal data set, proving the absolute necessity of active protection.
Makeshift solutions like cope cages proved ineffective against modern dual-stage warheads compared to APS.
NATO is working towards standardizing APS interfaces, allowing different systems to work on different platforms. Turkey developed the Pulat system, retrofitting their older M60 tanks to survive in the Syrian theater.
South Korea's advanced K-2 Black Panther was designed from the ground up to integrate active defense.
The next leap is AI. Systems that can predict attacks before they happen based on battlefield patterns.
Future tanks will share data. One tank's radar could detect a threat that another tank's APS intercepts.
Advanced APS could provide an umbrella of protection for vulnerable supply trucks and troop carriers nearby.
As hypersonic missiles enter the battlefield, APS reaction times must drop from milliseconds to microseconds.
The active radar emissions of APS make tanks easier to spot electronically, a trade-off for protection.
Crews will need to practice radar discipline, turning on the system only when danger is imminent.
It is an eternal game of cat for every shield mouse.
APS gives commanders the confidence to operate in complex urban terrain that was previously a death trap.
Most importantly, it saves the crew. A tank can be replaced, a trained, experienced crew cannot.
The psychological impact is immense. Knowing your enemy can shoot your missile out of the air is demoralizing. In the future, tanks might become lighter and faster, relying entirely on active defense rather than heavy steel. Tanks may soon carry their own tethered drones to extend the horizon of their APS sensors. The market for APS is exploding, becoming a multi-billion-dollar industry essential for national defense.
Even obsolete tanks can be made viable again with the addition of a modern active protection suite.
Critics have often declared the tank obsolete in the face of modern missiles. But technology like Trophy and Iron Fist has breathed new life into the Iron Beast.
The armor of the future is not just steel and ceramic. It is silicon, radar, and code.
It is the unseen guardian, watching the skies so the soldiers inside can focus on the mission.
War changes and weapons evolve, but with active protection systems, the tank remains the king of the battlefield, defended not just by armor, but by intelligence.